Hello, everyone. So, hi, I'm Gynvael. Now, I'm going to talk a little bit about myself, and this is because I want you to adjust to my weird accent when I'm speaking, because I will be speaking really fast today. And to do that, I'm going to tell you a little bit about myself, which is not really important or interesting. Perfect. So, hi, I'm Gynvael. I'm currently the managing director of Hexarcana and a security researcher there before I worked at Google and some other companies. I'm also the project lead behind this. So we are accepting articles for issue number 8. Please write something for us. And if you have any comments or something like a comment about an article or my article, which is there, just let me know. And I'm happy to get any feedback. Apart from that, I played in a CTF team called the Dragon Sector. If you played CTFs like, 8 years ago, you might know us. And I'm also an author of some books, a YouTuber, and I do a lot of other stuff, doesn't matter. Okay, before we begin, a couple of things. First of all, this bug, which I'm going to talk about, or other bugs, have been long fixed. Like fixed in 2021. So I'd like to thank the organizers for actually allowing me to speak about this, because I never talked about this in English in public. But yeah, just keep in mind that everything is already fixed, for better or worse. Now, also, thank you for coming, because it's a first talk of the morning, and you actually arrived. I am impressed. Thank you. Now, I'm going to focus on the devices which are in blue here. NETGEAR has a lot of devices, and especially I will be talking about this device, which is here on my desk. We might even have a demo if demo gods are kind for us. Now, NETGEAR has a lot of other devices. I cannot comment on the quality of the firmware there, but I will comment a lot about the quality of the firmware, of the old firmware on this device. Now, if you're wondering about these odd numbers and the letters here, I tried to decipher how exactly the NETGEAR versioning system works, and I have no idea. I'm sorry. Okay, so how did the story start? So the story started because I ran out of ports on my old network switch. Well, I have a home network, like everyone here probably, and I ran out of ports. So I needed a new switch. So eventually, I decided on buying this device because, well, it had 8 ports. That's quite a lot. And it also had these small factor pluggable thingies, which I never played with. So I thought, hey, a new toy I can play with. And it's also cloud managed and smart, but thankfully these features can be disabled. So I was like, yeah, okay, let me get that one because I actually really like the design, the metal casing of the NETGEAR devices. Cool. So I apologize. I will be coughing a lot today because I'm still recovering from a cold. Now, I got some other tools with my switch because I was pretty excited with it. So I got some fiber optics and so on I can test. I also designed a 3D bracket so I can attach it to my tactical mount on my desk because for whatever reasons my desk has one. So as you can see, I enjoyed the switch even before I turned it on. And when I turned it on, hey, it was actually working. So I did what any sensible security person would do. I went into maintenance. I went into troubleshooting. And there are usually options like ping and traceroute. And everyone knows that there's usually a shell injection there. So I wanted to test, hey, is this device secure? Can I actually use it without, worrying too much, right? So I go to ping, I test some things, nothing. I go to traceroute, I test some things, nothing. Hey, maybe this device is secure. So I go into, HTTP layer of the things and I do a manual curl. It's really cool in Chrome tools that you can just right click on a packet and you can select copy as a curl command. So it was really easy to do. And I inserted this string here. Oh, apparently this button does something interesting. Wow, it reloads I cannot use the laser pointer because it actually is F5 as well. Okay, good to know. So I did this typical command injection and I ran another terminal, not expecting anything because the switch is secure, right? And obviously the switch connected. So I was like, this needs some testing before I can use it. Okay, so time for bug hunting. But, well, let's introduce some rules of engagement, because this cannot be like any bug, right? What I want is I want a full exploit chain. I want something which, gets me from 0 privileges to actually being able to run stuff as root or be running stuff as root equivalent. What does equivalent mean in this case? Well, it means that if I can log into the web panel of the device, I can already upload any firmware because the firmware is unsigned, it doesn't have any downgrade protections and so on. So I basically assumed that, hey, if I can just log in as admin, I'm already root on the device. Now, I'm also assuming that the attacker is in the intranet, in the local area network, because, well, this is a switch, right? So switches are usually not exposed to the internet, at least they shouldn't be. So I'm assuming the attacker is already in LAN. Maybe it's a company and somebody just came to the reception area and like plugged into one of the available RJ45 slots, like pretty typical. Or the attack can be done, well, one of the options is like if we have a user which is in the LAN and the user enters our page with, funny kittens and so on, right? And the browser, the page tells the browser, hey, send some packets to the local IP addresses. This also counts. So if we can do a reflected attack like that. And because, well, every vulnerability needs a name, right? And a logo, right? This is the way you do things. Well, I'm going to use a metal band name generator to name the vulnerabilities because, well, my sense of humor. Okay, pro tip, because this is supposed to be a keynote, so some pro tips as well. The first thing you do when you do research is you make a new folder and you create a new document for notes, because when doing research, vulnerability research especially, you need a lot of notes. And usually I have like 20, 50, 100 pages of notes per research. If you're new to vulnerability research, make notes. This is the only lesson, keynote lesson from this keynote. Okay, so what do we have so far? Well, we already found this vulnerability, right? But a quick side note, what's the difference between a bug and a vulnerability, or a bug and a security bug? Well, if we have some privileges in the device, like the green circle on the left, and there are some other privileges which we do not have, so a bug, a non-security bug, is if we can trigger the bug on purpose, and the effect is within our privileges. So we could have done that anyway. But if the effect is outside of our privileges, which means we kind of gain some other privileges, then, well, that's a security vulnerability. So far what we had is this like shell injection, right? Excuse me. But, well, I had to be logged in as admin. I had to have a valid session ID to actually do this. So this isn't really a vulnerability, right? I already had to have admin. So that's a bug. That's a bug. It's a cool thing to know. It kind of tells us a story about the quality of the code, but this isn't a vulnerability. So yeah, severity, meh. So how do we get the firmware? There are actually 3 ways to get a firmware of such a device like this one. One way is to, just desolder the chip, put it in some programmer, and dump it. That's option 1. Option 2 is to unpack the firmware update. There are usually firmware updates on the website, so you can download, and sometimes they are encrypted, sometimes they are not. Sometimes you can just quite easily unpack them. The screenshot of entropy, by the way, is from a different device. Can you guess the architecture? Anyway, if you can, let me know. And the third option is, well, because I already had this shell injection, that means I could just copy files, right? And obviously everything was running as root on this device because, yeah, why not? So I actually went with option 2 and option 3, both options, so I could get like a live dump of the device and I could also get a firmware. Unpacking the firmware is like also a good question. How do you actually unpack the firmware? And well, I use the YOLO method. The YOLO method works like this. We close our eyes and then we run in turns binwalk and 7-zip, binwalk 7-zip, binwalk 7-zip. We open our eyes and suddenly the firmware is unpacked. And well, it works. And if it's stupid but it works, it's not stupid. It's one of the rules of engineering. Obviously, it doesn't work always, but hey, here it worked. Okay, let's talk a little bit about this hardware and the firmware. We already know it's Linux, right? This was a Linux command injection. We can assume it's probably not OS X, or Mac OS. So yeah, what is it apart from that? This is how the device looks like, by the way. It's not the same device. It's one of the devices which has the same firmwares, but it kind of looks like this. Also, that's my password. Please don't hack me. And yeah, so Linux with a kernel 3.18, not really modern kernel, was running there. It was a MIPS architecture, and it was the chipset there was RTL, so Realtek 838XM, whatever that means. So a somewhat not super powerful device, but yeah, hey, it can run Linux, so it's a little bit more powerful than normal dump switch. Also, it has 128 megabytes of RAM, which will actually be important a little bit later. When we look at the firmware, it was actually the thing which was extracted into the RAMFS was the base Linux system, but apart from that, there were a RAM disk, obviously, and which is usually in /temp, as you know. And apart from there were two squash-fs images which were mounted in /sqfs and /mod sqfs. This is pretty typical, nothing out of ordinary. Like Linux, this is the important thing to remember here. I decided to reverse engineer stuff with Ghidra. I didn't know Ghidra back then, so this was my first project with Ghidra or Ghidra, however you want to call it or pronounce it. And hey, it actually worked really well, and the compiler worked with MIPS out of the box as well, so I was pretty happy with it. So it's a good tool. Now, this everything was basically written in C for the web UI. So web UI and everything else was written in C. So yeah, we can already kinda expect some memory bugs, like memory corruption bugs. I didn't have too much luck with running the firmware on my PC. I could get some stuff to run with QEMU user and QEMU system, but not everything. So yeah, I could debug some stuff, but not everything. In the end, I almost didn't do any debugging. It was mostly reading the dead listing in Ghidra. Okay, so we have the firmware and we know what kind of architecture this is, so we can start. Okay, now the method I used was basically alternating doing a breadth first, so like enumerating all the attack vectors which are available, which was mostly the website, but not only, there were also other protocols on that switch, and other bugs were reported. And also going in depth in whatever I found interesting, and I did that for some time. Now, this is the quality of the code which I discovered. This is how you read a file. If you are a little bit into programming, you would expect there to say fopen/proc13 blah blah blah. But here we actually call the cat command in bash to output the content of that pseudo file. So yeah, that's not how you read a file. I have no idea until today, like, why would you use this code pattern? So let's say that the code quality was promising. Not promising as in it's secure, promising as in, hey, it's going to be a good hunt. Okay. So first bug or first thing which I found was this setup CGI bug. This will be fast because it's boring. Now, okay, quick question. Who knows what CGI is? Because that's an ancient technology. Okay, so CGI predates PHP even. Actually, PHP came to be because the author of PHP was writing some CGI scripts. So CGI is basically an interface between a web server and a normal executable. And it says that everything which goes to standard output of that executable goes to the client that connected to the web server. And what about, the path and the HTTP headers and so on? Well, this goes mostly into environment variables or into standard input of the process. And the process can be in anything. It can be in Python, in Perl, in Bash, in like C. In this case, they actually had most of these executables in C. So yeah, there was a server, an HTTP server, but this was outside of the executables which I was actually analyzing. Okay, back to our show. Now you know what CGI is. So first bug I found was that when you were actually initializing the token, initializing the switch, you could actually register it, I think, and I was analyzing the part which was doing the registration. Now, it turned out that there was some token passed there, and the token was passed into a function which was called sal, sys, whatever, doesn't matter. Now, what matters is that this was then passed to sprintf, which formed a command. And there are like two vulnerabilities on this slide. One is the obvious shell injection, and the second one is, hey, that's a buffer overflow, because there's no like size given. This is not SN printf. So yeah, two vulnerabilities, but the shell injection is pretty easy to exploit. There was no escaping, but there was HTTP encoding actually, or rather URL encoding that encoded some characters, but not all characters. So I spent like 15 minutes trying to get the proper exploit, proper payload, and the proper payload was the orange thing there, which was, I just passed the actual real payload in a header, and then the CGI interface made sure that it would go to an environment variable, and I just called the environment variable, which you can actually do in Bash. Another method was to do just cat there, cat with, dollar brackets cat, which will execute whatever comes on standard input. And what comes in standard input in CGI? Well, whatever you send in the post message. So yeah, pretty simple bug. I called it the feral terror because I wasn't kidding with a metal band name generator. And as you can see, I also used a heavy metal cover generator to make sure that I have a proper, well, let's call it logo or cover for the bug. And I saw that they had a bug bounty on Bugcrowd, and I was like, hey, can I report it there? But they had this rule of disclosure. This program does not allow disclosure. Translation, this means this company can take 5 years to fix the bug, and you cannot do anything because you will be breaking the rules. So I was like, yeah, how about no? And I reported it under 90-day policy, saying that, hey, if you don't fix it in 90 days, I'm going to inform the defensive community of the problem. But they did. Like, they actually were pretty fast with communication, and pretty good with communication, and pretty fast with fixes. So yeah, kudos to NETGEAR. I had some other issues with them. Like they didn't want to assign a CVE number because they have their own PSV numbering system, and they said, yeah, that's enough. But that's kind of weird because like almost everyone monitors the CVE database to look for vulnerabilities. I don't know what's the reason they didn't want to add it to that database, but well, I submitted it anyway, so it still went to the CVE database. That's one thing. The other thing, we kind of had disagreements about what is the actual severity of the bugs, but I will get to that later, or maybe now. They actually said that the CVSS score should be 8.8. I said, hey, it's 9.8 because we disagreed. What does it mean, an adjacent network? Yeah, whatever. Like, it's a terrible bug anyway, or rather a vulnerability. So then I went to buy some more NETGEAR switches because of reasons, and I did spend some time researching them, which was pretty fun. And then I went back to this switch, and I was like, yeah, they fixed all the bugs, right? So now I can look at it again. And in search of something more interesting, I decided to take a look, how does the actual login look for this device? Like, how does the authentication flow when a user logs into, how does it work? So you don't have to specify a username, that's one thing. You have to only specify the password. There's only one user, it's called admin, and that's fine. Now, if you type in the password, it actually runs this set CGI application with the parameters home, login off, which means that it goes to the right function. And then things start to get weird because in the post data, what's being sent, that's JSON. That's JSON formatting, right? Like you have a curly brace at the beginning, curly brace at the end is a dictionary, but the data goes into the key of a dictionary and not the value. And furthermore, the data in that key is actually, that's form encoding. Like, what's going on there? So that's kind of weird, but okay. So I was like, hey, they have some encryption there, right? Like my password, which I typed in, is encrypted. That's interesting, but something is not right. You can see I use the password Ala ma kota. That in Polish means Alice has a cat. It's something like a phrase you learn in the like first grade of primary school, basically. If you look there, you can actually find that password, but it's every 7th letter and it's reversed. So what kind of encryption is that? Security by obscurity, I guess? Anyway, well, it went to the server, and the server actually replied with status authenticating. And there was like an endpoint which would return whether it's authenticating, and after a couple of retries, it would say, yeah, okay, it's a good password or it's a bad password. If it's a good password, it would send you the session ID. If it's a bad password, it would just like say, yeah, no. So yeah, at some point you get, okay, end the session, which is a base 64 of session ID, which we will get to later. Now, how does this process work on the backend is absolutely fascinating as well. So we, from the browser, make this HTTP request. Then it goes to the server, and the server, there's a function called CGI util authing session create, which then sends a signal to a process which is called pull D. It's a daemon, it's a separate daemon is running in the system. And there's a function called, which is called handle pull D action, which calls system CMD, like some, calls a command, execute another process, which is called login CGI. It's called CGI. It's not a CGI script. It's like a normal standalone application. I don't know why it has the CGI extension. And what this does, it basically sets the status to 0, which means I'm processing the request for authentication. So at the beginning it's 0, and then it puts into the, it basically replies with 1 plus session ID on correct authentication, 2 on, hey, wrong password, 3 on too many password attempts, you're trying to brute force, I'm actually banning you for a couple of minutes, and 4, I don't know, I don't think that happens actually. And when we are querying, the browser is querying this get CGI home login status, we are basically getting the translated to JSON output of this, like this translation of 1, 2, 3, or 4 from login CGI. So, yeah. One bug which I immediately found here, which I named Draconian Fear, because again, heavy metal band name generator. Actually, between these two requests, there is no checking for any session. There is no session yet created. And because there is no session, anyone with the same IP address can actually come and claim the session ID. Just raise condition, call get until the administrator logs in, and then they get the session ID first. Now, hey, what's up with the same IP, right? In what cases can you actually have the same IP? Well, I apologize. This is a local area network, so there are network low-level shenanigans which allow you to have the same IP. Sometimes you maybe have an IP, outgoing IP address the same as admin for whatever reason. Maybe there are other reasons. There can be multiple reasons. Anyway, I reported it, they fixed it. Okay, here's a question, because this login CGI has to communicate the status to this get CGI, which actually returns it to the browser, an IPC mechanism has to be used, as in inter-process communication. Now, what IPC mechanism did they use? There are multiple of them available on Linux. We have pipes, we have Unix sockets, we have shared memory, we have even local TCP/IP socket connections, right? And there are other mechanisms. So obviously they have chosen the best one, which is files. If you ever done IPC, you're you don't use files for IPC, but there are problems. But they actually used a file which was called temp says and then graphical user interface, authentication, info, and PID. And this file had the following content. And this was a text file. This is text. As you see, username, Newline, password, Newline, the name of the file which gets the response, the status of the response, you know, that 1, 2, 3, 4, maybe the session ID, the IP of whoever is asking, whether they are using HTTPS or not, and what browser are they using, but this is as a number. So I think like Firefox was 0, Chrome was 1, and so on. I don't remember the exact mapping. And at this point, the moment I saw this, I was like, yeah, I got them. Like, I have them. This is a vulnerability. Why do I think so? So, you see, this isn't the first time I see this pattern. A long, long time ago, when I was in high school, I actually played a game which is called Ultima Online. Anyone played it? Probably no. That's an MMORPG from back in the days. A pretty cool one. I almost didn't pass my major exam due to it because I played a little bit too much. Anyway, a good game. But I wasn't playing on official servers. I was playing on like unofficial servers, which were running this software called Penultima Online, which is a server emulator created by the community. I don't think it was open source, but at least it was free. Now, there was at some point an interesting entry in the changelog. The author said, character creation will refuse to create a character with control characters in the name. Newline, for example. Why? Why is this important? Because, well, you see, this Penultima Online was using a database which was actually a set of text files, which looked like this. It's not JSON, it kind of looks like JSON with that bracket, but it's like a custom text format. So if we had created a character named Sauron, right, and we put it in the name would go into that database. But if we would create like a character named Sauron, Newline, command level admin, it would also go to the database. And then when the database would be saved and the database would be reloaded because the server, I don't know, crashed or something, then, hey, we actually have an admin. So a Newline injection in text formats is a problem. Back to our show. If we put the password while trying to log in as Ala Makota, then it goes here to the second line. And the third line is this file path. If we add a new line to the password which we enter, which we can do, right? We can send anything in a POST request, especially such weirdly formatted as this JSON form encoding thingy. Then suddenly we control whatever is afterwards in the line number 3, line number 4, and so on. So we control the path to where this IPC file is located, which means we can now put into that file, because we don't know the password, so we can put into that file 2 or 3. Well, probably 2, because we don't know the password, but we don't want to get, brute force it, so we get locked out. So we can use a new line. We can replace the status file name, and we can write the 0 at the beginning, and then it's overwritten with 2 to some other file. Yeah, this doesn't sound like root, right? Like writing one character to a file on a disk does not sound like getting root access, which is our goal. So I was like, yeah, great. I can write 2 anywhere on the file system because I control the path. Like, what can I do with this? It took me 5 days, well, 5 evenings actually, to figure this out. I was trying multiple things. But at the end of the day, I did actually figure it out. So, stay with me. Sessions are the key. I told you we'll get back to a session. Now, here is how, well, this is already what we saw at the very, very beginning of the talk, this shell injection, which I told you was not a vulnerability, it was just a bug. But I told you that, hey, because you need to be logged in, and therefore you have a session. Now, the session is in a field which is called CSRF something. So you would think like, hey, this is just a cross-site request forgery protection. But no, not really. It's actually also a session ID. And the session ID apparently goes into a function which does RSA decryption, and then it's used as part of a file name. The problem is we do not know the keys. We don't know the private key. We do not know the public key. So yeah, it's generated on the backend. The backend gives you the session. The backend never shares the key with you. I don't know why they used public cryptography for that. I would just use symmetric, but okay. Okay. How does a session file look like? Well, the session file is actually another text format with numbers. Well, and also the username, but username is admin. And when whatever script is being run and it checks the session, whether it's still valid, it actually uses the fscanf as in file scan format function from C, and you pass it like basically tags which tell what kind of variable is supposed to be read and filled from the file. D means decimal, U means unsigned integer, S means string. Yes, that's a buffer overflow because that %S should also have a number there which says what is the size of the outcome buffer. But let's skip that buffer overflow, it's boring. Anyway, so, well, we can create a file which has 2 in it, right? So is that a valid session? Well, good news is that fscanf can return like how many fields did it successfully fill. Here it would fill only 1 field. 1 field. So it would return 1. In this case, it would return, how much is that? 7. It would return 7. 7 fields are successfully filled. Now, here it would return 1. So the problem is like, hey, NETGEAR, are you checking it? And no, thank you, NETGEAR, you were not checking that, what fscan returns, which means I can actually just give you a file with 2, and everything else would be filled with default values. Yes, they did initialize the variables. There were actually zeros there and an empty string for the username. So cool. Hey, this could be a valid session. Like as long as, yeah, but we still don't know the file name of a session because like it goes, whatever we send in this header, in this XSRF, XID, XSIDs header goes to this RSA decrypt function, but we don't know the public key. Well, so it's a problem. But let's take a look how it actually works. Because there might be another bug there, right? Devil is always in the details. So it works like this. First, a global variable G_says ID is created and it's initialized with an empty string. Then the function to decrypt it is called, and it's RSA with padding. This is important. Why is it important? Because in cryptography, if you have a like naked, let's call it a naked function which does decryption, it cannot fail. It will just map one input with the key to some output, but it cannot fail unless there is some kind of checking. And padding is there to check if this decryption was done correctly or not, which means this RSA decryption, it can actually fail, which is good because it will probably fail. We can make it fail pretty easily. We'll just give it some garbage, right? Okay, what happens next? Then this G_session ID actually goes to this sprintf. If we would have a public key, yes, that would be another buffer overflow, but it's boring, we don't count it. But yeah, we would control then the path of where the session file is looked for. Obviously, if it fails, NETGEAR did not check it, which means second point for garbage input doesn't exist, which means we just use the empty G_session ID, which is an empty string, which means that if we give garbage to that header, the file which it will look for is login HTTP_ and nothing more. So hey, we actually can control the file name. Well, at least we can select the file name, not really control it, but that's something because now we can write 2 to that file. So where are we at? Well, we can create a valid session file. We can write 2 to it. All the zeros there will be just default values. They will not be in the files. So in comparison to the real session, it looks kind of boring, but hey, it's a session file, right? The problem is that these numbers there are actually the timestamps of when the session was created. Well, that's bad because 0 means it was created a long, long time ago. But hey, these aren't Unix timestamps, right? Like Unix timestamp would have like 10 digits. This is not 10 digits. This is 8 digits. So what is it? What kind of timestamp is it? It's actually the time in milliseconds since the system was started, which means that, hey, this is a valid session just after the switch boots up. Or it could be. So, okay, now we have to find another bug. How do we reboot the switch? And, well, it's an old kernel. Maybe we can DOS it. Maybe we overwrite something important with that 2 on the file system. Or maybe we send an HTTP packet so big that RAM runs out. At the end, what worked was this thing, like the least likely thing, but hey, it works. Now, here's how it works. What we do is we upload a large file to the device. Why a large file? Because, well, there is no read-write file system there which isn't a RAM device, right? It only has a RAM disk, because SquashFS, which I told you about, was actually read-only, and the main file system root, that was also a RAM disk. So, hey, everything that is written to the disk actually should go to RAM. And maybe if it's not written to the disk, it's like just preserved in the memory of the server. Well, that's memory of the server, that's also RAM. Which means we can maybe overflow this 128 megabytes of RAM, which the system has. Probably less, right? Because probably the system is already using some of that. Yeah, the problem was that large HTTPD, the server which was there, the HTTP server, actually saved 1 megabyte files which were more than 1 megabyte to the disk. But as I said, we only had RAM disks available. So if it's a RAM disk, it means it's TempFS, it goes to RAM. The problem was that the switch did freeze, but it did not restart. Excuse me. Now, one important thing, if you're a little bit new to HTTP protocol and how HTTP works, you might be wondering like, hey, how can you upload a file if you cannot log in as admin and go to any upload functionality? When in HTTP, you can actually upload stuff to any endpoint, because usually the HTTP server, which receives the file from you, has no idea whether the endpoint accepts a file or not. So it just has to accept it, and it has to preserve it before it can run the proper script, and the script can decide like, hey, I'm going to use the file or I'm going to ignore it. Which means, yeah, you can always upload a file to any endpoint. It might be just that the file will be ignored. Okay, but what do we do with this freeze that the switch does, right? Like it freezes, it doesn't reboot. Well, the answer was funny. Because I have a bug which can write 2 into any file, I can also write it to this proc/sys/ blah, blah, blah pseudo files, which are responsible for kernel configuration. And a reminder, everything is running as root. So yes, I can reconfigure the kernel by just writing 2 to proper files. And I actually found files like endpoints, which I can reconfigure, which is like panic on out of memory, panic on oops. And I written 2 to them. And hey, this actually works. It reconfigured the switch to reboot on out of memory condition. Okay, so the full chain looks like this. Step 1. We run the exploit 3 times to reconfigure the kernel to make sure that it will reboot at the moment we will flood it with this large file upload. Then we send a file which is too big, and it actually has to be sent pretty slowly, because if it's sent too fast, then actually something breaks and it gets disconnected. But we can send it slowly. After 54 megabytes, by the way, the switch actually reboots. And then, this is where we go to the demo. Because rebooting the switch takes around 10 minutes, I didn't want to demo that part, so I'm going to jump in from here, and I'm going to run the switch now. I'm going to connect it to power. So let's pretend I did run the reboot, and it just is going to power on now. Okay, it takes a moment to boot, actually. Okay, so now we have to wait until the switch restarts. We have pinging of the switch here. We will know that it has restarted when that actually is, showing something. In the meantime, I'm going to, show you the exploit. That's 7 stage 2. And what I need is, what it will do, it will create a new session. After creating a new session, it will call that bug, the shell injection from the beginning, which was a bug. Well, now we are admin, so now we can use it to run commands, because, well, we are admin because we have a valid session. So I'm going to run a command which cuts this file, and it actually sends it to my server. Okay, I see the switch has restarted. So I need to create a server. What's the port there? 1234. Okay, so I'm listening on that. And it's actually curl, right? So it should be a HTTP server now, but doesn't matter. We are just going to ignore the headers. And now we can run the exploit. Now, please note that this might not work because it's unstable, so we might have to run it a couple of times. Yeah, not authenticated. And there we go. Now, why did I output this file? Because this file, for whatever reason, has the plain text admin password. Well, great, thank you. So now we have the admin password, and now we can use this password to actually go to the web UI of the switch. Yeah, not registration, skip registration, access. I have this saved, of course, but I'm going to copy-paste it. And hey, we are in. Hey, a live demo worked. This is a good sign for the conference. Okay, so what happened is we created a fake session in this file, and then we just send like garbage in that session header. And because it was decrypted as nothing, then we could control the file name for the session. And then we could use the bug, because we were already admin at that point. We had a valid session, right? Well, at least for 5 minutes. But it was valid for 5 minutes, and that's enough time to, for example, just send the password to ourselves, and we can now log in as a legal admin using using the credentials and getting a proper session which has, and we can just repeat it without rebooting the switch ever again. Okay, so that worked. Obviously, the next step was naming the bug, and I called it 7th Inferno because reasons. Again, NETGEAR didn't want to assign a CV, so I had to do that myself, so we got a CV. And we also disagreed about the severity, but yeah, whatever. Like, choose whatever version you want. It's long patched anyway, and you want to patch it probably either way if you have an old device. Now, one more note before we go to the summary. The demo almost didn't happen, because this isn't the switch which I was exploiting. This is a new switch which I bought for the conference so I can demo it. What I found out yesterday sitting in the hotel room is that, hey, you cannot downgrade the firmware below a certain value which is written into the ROM at factory level. So if the board is like, the PCB board for the switch is created after now, then you cannot downgrade below the firmware which was available at that point, which it's just a soft protection. It's not really a downgrade protection, right? It's because maybe something changed on the PCB and the older firmware doesn't support it, so they don't want you to brick your own device. And I was like, yeah, great. Now I cannot downgrade it to the firmware, which was like 4 years ago. What am I going to do? And, I could just say, yeah, sorry, no demo. But I was like, yeah, no, I'm just going to waste 2 hours trying to figure out how does this work to bypass it. And yeah, I just bypassed it by overwriting in the firmware the version number and recalculating checksums, and that was enough. So yeah, there we are. Cool. Summary. It's an amazing firmware. I can really recommend it if you are into vulnerability research. If you are into having great switches which are secure in your network, you probably want OpenWRT or something else like that. And what I like about the bug is that it's like a truly full stack bug. Like, we had web security and HTTP protocol. We had reverse engineering of MIPS binaries. We had crypto, but RSA with padding, right? And we had OS level stuff like reconfiguring the kernel. So hey, a full stack bug, cool. And as usual, the devil is in the details. So if something does not work, the question is always, why does it not work? What exactly happens? And if you dig into it, you will actually find sometimes a way to bypass the problem. In the meantime, I found other vulnerabilities like Demon's Cries, because heavy metal band name generator. And you can read that on my blog if you're interested. So that's it. Thank you very much for your attention. And please remember to write an article for PageOut. Thank you. And also have a great lecture if you're going to read it, actually. So happy reading the design. I'm really happy that it actually was printed by the organizer. So thank you very much for that. And it's always great to have it made available for an event. Okay. Are we doing questions?
Yeah. Thank you for coming and for your good presentation. Very interesting. Do anyone have a question?
We can do simple questions.
Yeah.
Why was Why was it important for you to have it assigned a CVE number?
Sorry, could you repeat?
Why was it important to you for it to be assigned a CVE number?
Oh, why? Okay, so why is it important to have a CVE number? Oh, wow, this is a great discussion, by the way. Okay, it's like this. If you're a junior researcher, you want a CVE because you heard it's trendy and you want it and you want to put it in your CV, right? And then when you get more senior, you kind of start to understand that, hey, the CVEs are actually there as for a purpose, and they are not there because it's a trophy. The reason CVEs exist is because it's a vulnerability database. And if you run a company, what you do is you have like monitoring scripts which read through this database of vulnerabilities which were discovered, and you cross-analyze it, or you check if any software which you have in your company is actually on that list. For example, it had appeared yesterday, because that means, hey, maybe you have to look at the vulnerability and you have to decide whether you want to patch it. Okay, and that's telling me I am out of time. Anyway, so you want to put vulnerabilities which you discover into the CVE database so that the defenders, which actually care about this, are notified. This is the great way to notify the defenders. And that way they are like, yeah, hey, there's a new vulnerability, maybe we have to update the firmware, or maybe, hey, it's garbage, and we don't have to do anything. So that's a reason which is why do you get a CVE number. It's not a trophy. Okay, it's also a little bit of a trophy, but the main reason is you want to notify the defenders. Are there other easy questions? Or hard ones? Okay, can we do it like one question there, and see what's the stamina of the organizer?
So thanks for the talk. How do you submit a CVE, actually?
Okay, so if you never submitted a CVE, it's like this. And it was 4 years ago, so things changed. But you can just go to the NETGEAR.org, like that's the organization which runs the CVE database. You can go to their website, and there is a form which you fill out. Now, you fill out the form, and you say like, hey, this is where the report is located, this is the version affected, this is when it was patched, this is a short description of the vulnerability. If you fill it incorrectly, it's going to be ignored, or because it's going to be probably put on the stack of like, hey, we have to fix the description, and maybe when we have time we will do it and it will go into the database. If you fill it out perfectly, it goes to the database really fast. They are just like, hey, it's filled okay, we just approve it and it goes to the database. Now, in the last 4 years, what changed is that there are more SNAs, which are the organizations, like other organizations got to govern the CVEs for their own product. So you can, like, for example, I'm not sure if NETGEAR is a CNA, but there are some organizations where you go to the organization and they actually have to get the CVE. And they actually decide which vulnerabilities get a CVE. If you disagree with them, I think you can always fall back to NETGEAR and you can complain that, hey, this is an actual vulnerability, but the organization doesn't want to add it to the database for whatever reason. It's an interesting discussion, basically, whether it works correctly, but yeah, it's like this right now. But what I can suggest to do, if you're interested, go to the NETGEAR.org site and read a little bit what are the options when you want to add a CVE to a database.
And the last question.
Again, thank you for the talk. So, if I really understand it, there was a file with the username and password in clear text. So there is a shortcut where you can just cut the file with the password and then access the web panel and upload your firmware, and it is.
Sorry, you'll have to repeat that.
Okay. So when you was doing your exploit, your Python exploit, you said that you have cut a file with a username and password of the admin. If I understand it.
Here?
Yes, and so there is a shortcut in the exploit when you can just output the username and password and access the web panel.
You mean, sorry, do you mean about this file?
No, maybe I don't understand it correctly, but when you...
I think it means that as your goal with the exploit you demonstrated was to cut the SNMPD file which contains the password, as you have the current command, you could also have exfiltrated the credential that way via this first curl. And yeah, bypass the to overwrite and all.
Yeah, that's also an option. So basically, honestly, what I had here originally was a reverse shell. But I didn't want to go into the whole discussion of how to compile a reverse shell into that platform because it was a little bit annoying. So what I ended up just doing for the demo purposes was basically this. And there are other ways also to do it. We can discuss it like after the talk also. Okay, thank you very much.
Thank you.